Thank you for the invitation. So it will be a completely different talk, I think, to the other ones. It will be more related to the keynote this morning. It will be a high-level talk where I give you an idea about basically what's here on the title slide, data seen as fuel and analytics as an engine of a digital transformation. So by doing this, I try to quickly demystify some terms. Then you see a little bit where are the challenges, what opportunities there are, and I give you some principles of success. These principles of success are the summary of what I'm doing since 17 years. So you will get the slides so you can read them out myself, who I am. I did my studies at EPFL, I did my PhD in EPFL, 2001. I started a company doing data analytics services, primarily doing what's called nowadays data science. I called it data mining at the time. Everybody told me 17 years ago, you're crazy, there's no future. 70 years later, apparently there is some future. And the thing in Geneva, this is what I'm doing for fun, because I want to give something back to academia. So there I founded a new master program in business analytics, knowing a little bit the needs in the real world, and to prepare the students for the future ahead. What I'm doing, and this was mentioned just briefly, what I'm doing a lot of nowadays with the company, I'm doing strategic consulting. I'm helping companies, so boards, board of management, board of directors, to tackle analytics from a strategic top-down approach. What does this mean to get the skills in a company? How to make analytics production ready, also really strategic consulting. And this is exactly one thing I do, for example, here with the director of the Swiss Federal Statistical Office, more later on, but I also have this with other Swiss and European companies. I'm also consulting Eurostat on these aspects, what has this to do with the single digital market. So it's really high-level strategic consulting. I'm also one of those influencers. So I do not trust in these ranks and all stuff like this, but you get a visibility you cannot imagine as a statistician by training. So I'm among the top 100 in data science, big data, IoT worldwide as an influencer. Doesn't mean that all guys there know really what is data science about, but it creates you free marketing, and this is something a little bit our community is missing in the past, is this marketing engine which comes with this hyping thing. So Statu Consulting I founded in 2001. This will be the only formula you get in this talk. So 2001, 17 years plus epsilon. Because I'm a statistician, so we have epsilons, uncertainties everywhere. Okay. This is about just my margins. This is my publicity slide. So I'm originally from Zermatt. So as a baby, I saw this. Through education, it became this Gaussian distribution. With 17 years of experience, I can tell you this distribution does not exist in the real world. So let me start by with demystifying. Demystifying I give you a little bit a type of definition on terms which everybody gives different definitions. I start with the first one, which is big data. So quoting Michael Dell, who said, here in Texas, everything is big. We just call it data. So big data, the term is from 1997, and it's really become a religion in the past. Now there are new religions coming, but this was really let's call it a religion. So what is big data about? It's really about data management, about architectures, about infrastructures, about putting in place hardware, software, in order to cope with the data flows we have nowadays. Now it's clear if you want to do this, you should do it in a way which enable you to learn to make sense out of this data, to do basically analytics. Otherwise, it's a waste of money. And this a little bit now, if you tackle this only from an IT point of view, you will not respect statistical principles, statistical rigors, respect to data collection. But it's really about management architecture, which should enable data-driven or data-informed decision-making or policy-making or whatever. There are several definitions about big data. There are these famous V's. I will not re-explain what is volume, variety, velocity. But the point I want to put here, you can have the best infrastructure architecture in place if you don't have this V here, which is the veracity, which is the trust in the data. How good is the data? How reliable are the measurements? This is quality over time. Is the measurement system capable of measuring the things correctly? Do we have valid data? With it comes the quality of data. So if you have the best architecture, if you do not pass this veracity filter, you should stop. There's no sense to learn anything out of these data. Because the data, you cannot trust it. And now there's a little bit of a challenge for a lot of companies because they never tackled data quality before. And now comes big data. And they start thinking about data quality. So if you were never able to tackle data quality in a simple Excel sheet with 100 rows, 5 columns, how will you tackle this with these data sets? So it's really about augmenting existing data quality frameworks. So this is the veracity. Now we have another V which came in, which is the value, which is the usefulness of the data. Here a quote here from Digital Switzerland. So data is part of infrastructure. Data is seen as infrastructure. On a European level, data is seen as the newest economic asset. So if it's infrastructure, we have to generate some value. So society, businesses have to do something with the data. So this is the V, which is the value, which is the usefulness. So let me summarize this. This gives me my 5 Vs. Volume, variety, velocity. These are like the ones which define it from our IT point of view. And veracity and value are the ones which qualify the use of the data. As you clearly see here, veracity is key in the game. Now, this is this religion. Now came this new religion. We have had several the talks already today, IoT, or industrial Internet of Things, smart things. Now we have edge intelligence and all things which come out. So here you have an example. My coffee machine just on, followed me. Now, what is IoT about? IoT as a term, once again, it's from 1999. It's this new religion here. As was already this morning in one presentation, it's not about things. It has nothing, this is the marketing part. It's about data. So if IoT is about data, here's an example about a smart city, an example from a Cisco study. So a city of 1 million will generate 2 million gigabytes of data per day by 2020. And you're not speaking about things, this is about data. This means if it's about data, I have my 5 V's of IoT data. And once again, we have the veracity, which will be the key. It's the veracity which makes the city smart. It's the veracity which builds up trust in the systems, which builds up trust in the data. As Edward Demings already told us in 1942, so this was the statisticians, data is not taken for the museum. If nothing is to be done with the data, why should then you collect any data? Now just think about how many companies nowadays collect data on anything without an idea what to do with the data. So clearly the data should provide a basis for action. And this is exactly now this idea here. Data is only the fuel, and analytics, this learning from data, is making sense out of data. This is the engine of this digital transformation. So there are 2 waves of digital. One, you have to get data, but the real digital transformation comes in place when you learn systematically with a scientific mindset from these data. So this is analytics. Now, what is analytics? There are basically 2 approaches. And this is also a different paradigm you're facing. There is this traditional statistics, and then there is this data science. So what is traditional statistics about? There was an idea, and then you tried to collect the best data to check your idea. By doing this, in the data collection process, you took into account the data quality issues. And then you got the data, you learned from this data, and you search for an explanation or confirmation of something. So the idea here was to evaluate ideas, idea can be anything you want. The question whether it will be rain tomorrow or not, just an idea. And this is from an analytics point of view, this is deductive reasoning. Because idea first, then data. This is traditional statistics. Now what is then data science? So data science is a rebranding of data mining. And the term data science was coined by a statistician in 1997. And the idea is here that you have so-called secondary data, whereas with statistics you have so-called primary data, because the idea was first. And here you have secondary data. Now the key point is here, this is also called observational, found, organic, convenience data. The idea is, you as a company, you as a business, you didn't have control on the data collection. Just think about, you have primary data on your customers, and now you buy in a smartphone, a step counter or something from an external company, you don't have control over these secondary data sources. And as these are not under our control, you're not only allowed to create new ideas out of it, because this is not primary data. And by doing this, you use predictive approaches. You use very complicated models, can be things like deep learning, can be different things, in order to generate ideas. And from an analytics paradigm, this is inductive reasoning, because data is first. But once you have an idea, you need to confirm it. This means you need to think carefully about applying traditional statistics. Everything was labeled under A/B testing, etc. This is the application of classical traditional statistics. This means, in this case, where does now artificial intelligence fit in? So here, artificial intelligence is much more than machine learning, but say the machine learning algorithms or these learning machines, they're not intelligence, they learn inductively by analyzing data. So they have at the beginning a data infusion step where data is put into the process and learning starts. And this is clearly an example of inductive reasoning. And what's clear here that you need both words. This means you need the traditional approach to confirm, and you need the modern approaches to generate these ideas. And you need both approaches for reasoning, and they are complementary. It's not a question of statistics or data science. The question is statistics and data science. And the question is now, depending on the data you already have, where do you start? Do you already have primary data? Or do you have basically secondary data? Then you first generate the idea, you confirm it. By doing this, you continuously learn things about your processes, your services, your customers, etc. And basically, it's like a never-ending loop. What you get, you acquire systematically by using statistical principles to confirm it, you acquire knowledge. So this is the idea of continuous improvement. And this is doing analytics, because you want to continuously improve. This morning in the keynote, he showed an example of an IT business case, the feedback loop. This is exactly now. If this thing goes into play, with such a usability, you even don't notice that you're taking part in this cycle. This is how the apps in Google and companies are working, because they automatically do the statistics and data science loops interactively. So what's clear here, that neither exploratory nor confirmatory is sufficient alone. You need both of them. This is a wake-up call, I think, for both communities, because nowadays we have data, we need both of them. And now, what is the basics needs here? So this is an inspiration with respect to Maslow's pyramid of basic needs. We heard a lot of presentations about AI, deep learning. There were presentations here about A/B testing. At the heart of everything is data. It's not the question whether deep learning makes sense. For me, it's a question where do you have the veracity in the data, the right data to apply techniques like deep learning. So the question has to go back from the algorithms to the input to the algorithms, which is to the data. This means here is the data collection is here. This means you have to treat this from a strategic point of view, because nobody will give you budgets to make a project in a company half a year to investigate data quality. But if the C-levels tell you this is our strategic asset we have, if you put this top down, ensuring veracity, the data quality becomes imperative. Any things which has to do with learning by data, the data has first to be checked for trust, for veracity. And if this is tackled strategically with leadership, things hopefully will work. So what are the challenges? I think one of the challenges is the veracity data. It becomes more important than ever. And this is symbolized a little bit here. You have here data which is put in a machine. There is some output. The question is here, before you do not trust this thing here, you do not expect that some magical techniques, and there's no magical techniques. A deep learning is an over-parameterized parametric nonlinear statistical model, which comes from the 60s, 70s. But the idea, I'm not against, I'm consulting projects where they do deep learning, but there they have the right data for this type of methods. So the question has to go back not on the output side, but really on the input side. And this has to do with trust you have in your data. This means you have to tackle this from a strategic point of view. Key elements are statistical principle, rigors of human. By statistical principles, I do not expect that everybody becomes statistical experts. There are, you have to know them. Statistical principle has to do with really also having this engineering mindset, this scientific mindset, this scientific discovery thing, that there is uncertainty, we have to control, we have to measure this. And this is what statistics is about. This is a mindset, this is a thinking. Analytics is an aid to thinking and not a replacement. It's about, and we heard this in several presentations, I heard this, it's about augmentation. It's about augmenting humans. This means humans have to accept, nowadays you have two jobs. One, you have to do your job. But the second point is you have to improve the way how you do your job. And a lot of industry, if you do not do this, one day you will lose your job. So it's really about augmenting the strengths to become more powerful. So here you have a small statistician here. He's not normal. You see, I'm not normal. And he's augmenting with technologies because the technologies are enablers. And it's not about making Robocops. It's about making this augmented statisticians, if you want, or augmented data scientists. Now, what is then digital? So digital strategies has nothing to do with technology because technologies will change too quickly. So you cannot tackle digital transformation with a strategy which takes into account we use this technology, we use R, we use Python, then in Python we use this module, in R we use this package, and then this will not work. So you have to tackle this differently. You have to target improvement in innovation. In this session, you have to change the way business works. You have to change the way the daily work is going on. So it's not about technologies. So what are then some key principles for success? This is like, I can tell you, it's like a summary of my 17 years of consulting experience on one slide. If I explain it to you, you will see this is common sense. But this is a little bit forgotten nowadays, that you should not neglect these four principles. And there's a fifth one which comes just afterwards. The first one is using sequential approaches, iterative approaches, to problem solving, to continuous improvement. This means this proof of concept world is over. You cannot do proof of concepts. There's a complete misnomer. It could be it works. You have to admit, with one analysis you find something, with the second one you continuously use. So there's still companies who want to do proof of concepts in analytics. This is nonsense. Because, however, what you can do is quick wins. This is something else. So it's about sequentially approaching and continuously you want to improve. The second point is about having a strategic thinking. You have to have a strategy of the project, how to measure, how the business measures success, how to conduct the analysis, who's doing the analysis. You have to check whether you meet the objectives maybe of research or here of business. Otherwise, you will have a gap between what's done by the data scientist and what the business needs. So this is a strategic thinking. The third principle is what I call the data pedigree. So this is the pedigree which goes into this game, which is the data. So you have to carefully consider quality. You have to access the data pedigree before you do analytics, during you do it, because you will do feature engineering or stuff like this. You may destroy your data. And if at one point you just randomly replace missing values, you destroy your data, you will have garbage. And so you also, when you do the analytics, you have to carefully think about data quality, and also once you deploy the results, because data will change. If there won't be any changes, we don't need analytics, and everything will be always the same. And this means we have to carefully assess the data pedigree, and the first principle has to do with the fact no external consultants can come to your company and solve your problems, because you have to make your homework first. You have to apply sound subject matter knowledge, you have to apply your domain knowledge, your business knowledge. You have to get an understanding of the context, of your processes, because you have an idea about your processes, how your processes are operating currently, where you could improve. It helps you to define the problem, to give you an idea about the data pedigree. It guides you on the analysis, or he guides you to the external company who does the analysis to help you, and he helps you interpreting the results. So all improvement takes place project by project in no other way. And always have in mind, those who still remember this song, put this on your smartphone. It's getting better, a little better all the time. And then if you get brainwashed by this song, every mistake, every problem promised to not exist, there's an opportunity to improve. So you have to accept this. And if you always have the Beatles song in your mind, then this will help you. And now let's tackle this strategic thing. So this, I know Bill since a long time. So this is from him. So organizations do not need a data strategy, they need a business strategy that incorporates big data. And this is exactly what I'm helping now companies, not only the Swiss Federal Statistical Office, but also bigger companies in Switzerland and throughout Europe, putting in place top-down strategy. This is an example of a top-down strategy, which is in the public domain in 4 languages, which is called here a data innovation strategy. You can go there, you download it, you read it, and you can apply this. You see there's most of the things, you see a copy and paste of my slides here. There's ideas which are here, how to put it in place, how to implement this. This is coupled to a multi-annual planning of the Swiss Federal Confederation. So this is a top-down strategy, how to put things like what in place, what's called complementary methods, machine learning, data science and stuff like this, with a top-down strategy in a Swiss federal office. So it's like creating this entrepreneurship gene, this startup culture in a Swiss federal office. And I'm doing similar things in the private sector, but there the pain is larger than in the Confederation. But progress, it goes on. And what I noticed, this is why it's the first principle, not only in the relationship with respect to the Swiss Federal Statistical Office, it's clear you don't know how the future, where it will be, but I also noticed is the 5th principle is this one here. So next time I would need to add it on the previous slide. Culture eats strategy for breakfast, lunch, and dinner. And do not let culture eat strategy, they have to feed each other. This means digital transformation, it's not about technology, it's good if you have a strategy which is aligned to your business strategy, but what's key is the culture change. It's breaking out of this old-fashioned way how the things really breaking out to change the minds, to change the culture. It is a little bit I underestimated when I started several years ago this type of consultancy, because if the culture is not changing, it will be difficult. You can have the best analytics teams, the best center of analytics, center of excellence. You can have the best technologies at one point, the best veracity of the data. If the culture change is not happening, then it will be difficult. And this is in relation to what Stemming already told us in '82. The transformation can only be accomplished by man, and women. I have to modernize this definition. Not by hardware, so computers, gadgets, automation, new machinery. This means a company cannot buy its way into quality. And this is a little bit what's forgotten nowadays, because it has to be done by humans, and culture change is a human thing. Now the problem is, it was mentioned before, in the keynote this morning, apparently Switzerland doesn't have any paints, so why should they then change? So there's another saying of this, which is Mark Twain, which once said, the only person who likes change is a wet baby. So this means Switzerland, a lot of businesses need more wet babies. If you get more wet babies, because they want to change. Maybe not at the beginning, because they feel comfortable still maybe for half an hour, 1 hour, but at one point they want to change. And this, once again, the only person who really want it are the wet babies. So do we have enough wet babies or not? So I hope this was interesting a little bit, to give a little bit of high-level overview a little bit about the context. That it's wonderful to have wonderful analytics here on the operational level, but you also have to guarantee that the gap is not too large between, say, the strategic thing at the top and the operational at the bottom. Thanks for your attention.